Over the last couple of units to close out the course, we'll be picking up a few loose ends and looking at some aspects of management that we need to touch on in order to give a more complete picture of management at the institutional level. So far, we've been looking at things mostly from a project point of view, and that's practical because the project is the basic level at which teams address new goals in an organization by meeting objectives that lead to positive outcomes. But there's a bigger picture at the institutional level if we step back and take a longer look. If we think back to PM Bach and the definition of a project, we know that projects are temporary with a beginning and an end, that they are unique, and that they are designed to accomplish a singular goal. We've spent quite a bit of time talking about the specifics of projects, including how they break out, the different phases, how to plan projects, tools to implement, and how to evaluate projects. We've also alluded generally to programs and operations as being longer term than projects, but we haven't really given a definition to programs. So let's do that now. In the context of an institution or enterprise, a program is a group of related projects managed in a coordinated manner for the purpose of obtaining benefits not available from managing them individually. Where projects result in short-term concrete deliverables, programs deliver the longer-term strategic goals and objectives. Institutions may have multiple programs, each consisting of multiple projects. It's also possible to have projects that are not connected with a particular program. Program managers may manage one program, multiple programs, or combinations of programs and individual projects where project managers report to the program manager. A group of programs or collection of programs and projects is referred to as a portfolio. In a portfolio managed by a program manager, the individual programs or projects do not necessarily need to be interdependent or directly related, but the grouping should meet a strategic business objective. Program and project manager roles are necessarily different, and knowledge and skill set will vary depending on the institution and its market. A software company, an automobile manufacturer, and a library, for example, will have very different requirements for individual project and program managers, even within the organization. But we can make some generalizations. Project managers are in charge of individual projects and direct individuals on their team to produce on-time, short-term tactical deliverables. In order to do that, they use tools such as Gantt, PERT, and work breakdown structure to track detailed project progress and then provide summary project progress to the program manager at the next level. Program managers, on the other hand, have a longer-term strategic view of the institution and are focused on the summary reporting of the project managers who report to them. Their everyday go-to tool is the dashboard, which consists of reporting tools that summarize data from multiple projects. These could combine, by way of example, charts that display the % completed figure from each of many projects or budget summaries from many projects on a single screen. Basically, program managers use dashboards to track key performance indicators across multiple programs via scripts that aggregate summary data and present it in mostly visual forms for easy tracking and detailed follow-up where necessary. I've included an article by Eric Mitchell in your readings that covers dashboards for program management in libraries that will give you a good picture of what program managers are looking for in information organizations. There are a few other tools and management approaches that larger institutions and enterprises use to eliminate waste and improve the bottom line, either to improve service or profit. And I'll now talk briefly about them and how they've been adapted by information organizations. After World War II, when Japan started to rebuild its manufacturing base, it was known in the U.S. primarily for turning out cheap, poorly made plastic junk. The term made in Japan was synonymous with poor quality. But in the mid-1950s, Toyota began to design, with the help of an American engineer, what became as the Toyota Production System, a precursor to two management philosophies, lean and total quality management. The Japanese approach really changed things, and it took decades for American auto manufacturers to come up to the standards for production quality set by Toyota. Lean focuses on eliminating waste, and total quality management, or TQM, focuses on a constellation of factors that vary somewhat depending on whose book you are reading. Most agree that customer focus is number one, and that the entire organization must be involved. TQM is process-driven, and management must be strategic, that is, relate to the strategic plan. Decisions are fact-based, channels of communication are effective and systemic. The organization strives for continuous improvement in all aspects of its operations. There are a couple of other factors that are sometimes mentioned, such as mutually beneficial supplier relationships. To implement TQM means essentially to do all of these things, hence the T for total. However, in reviewing a number of sources, I've concluded that there's no widespread agreement as to how organizations go about implementing it, although there is an ISO standard through which an institution can be certified in various areas. There are examples of libraries that have adapted components, such as statistical controls with integration into decision-making, customer-focused initiatives, continuous improvement review, and so on. And this has been shown to result in improvements in library operations. I've provided a survey that shows differences in implementation of components of TQM via surveys completed by libraries with and without ISO certification, as well as comparing differences according to accreditation by different agencies that you might find interesting. There's also a case study of a library with justification for implementing TQM. So, reading those will help you understand how managers and leaders will implement customer focus and continuous improvement in library settings. If TQM sounds a little squishy, then Six Sigma is its more rigorous kid brother. Sigma is the symbol for standard deviation, and Six Sigma refers to pushing your manufacturing defect rate from 1.5 standard deviations on a normal distribution curve. You may have heard of this called a bell curve, to a rate of no more than 6 standard deviations on that normal distribution curve. In practical terms, that means you would have no more than 3.4 defects per million manufacturing steps. Although this is somewhat of an oversimplification of the Six Sigma process, you might recognize this if you've had any statistics or research methods class. If not, let me just say this is pretty hard to do. The process to get there mostly came out of work done in the mid-1980s at Motorola, and then came to prominence when Jack Welch adopted it at General Electric in 1995. In most manufacturing companies, it has largely replaced TQM because it comes with a suite of management and statistical tools that can be used to improve the data-driven decision-making that TQM requires, but which doesn't explicitly provide a method. Although not formally tied to Six Sigma, the method of process control and problem-solving procedure usually used to achieve this Six Sigma is an expanded variation of the Plan, Do, Check, Act cycle, called DMAIC, for Define, Measure, Analyze, Improve, Control. Like PDCA or Plan, Do, Check, Act, this is a cyclic process that operates repetitively in order to assure continuous improvement in all phases and at all levels of the institution. But it's primarily, as originally conceived, a manufacturing improvement methodology. At Define, the objectives are to identify and/or value the improvement opportunity. define critical customer requirements, document processes, and establish the project charter and build the team. At measure, the team measures and determines what to measure, manages measurement data collection, develops and validates measurement systems, and determines Sigma performance level. At analyze, the team will analyze data to understand reasons for variation and identify potential root causes, determine process capability, throughput cycle time, and will formulate, investigate, and verify root cause hypotheses. At improve, the objectives are to generate and quantify potential solutions, evaluate and select a final solution, and verify and gain approval for final solution. Finally, at control, the objectives are to develop ongoing process management plans, mistake-proof the process, monitor and control critical process characteristics, and develop out-of-control action plans. At this point, the cycle begins again. There's an alternative to DMAIC, known as DMADV, or Define, Measure, Analyze, Design, and Verify. That runs similarly. I have no idea how that's supposed to be pronounced. You can Google it if you want to know more. At this point, there are too many acronyms for me. Within these methodologies, the tools used are primarily those of inferential statistics. If you've had a research methods class, you will recognize these. I believe we covered this in our research methods class here. If not, if you take an intermediate, advanced, or PhD level research methods class, you'll certainly recognize these ANOVA, or analysis of variance, and its many variations, regression, correlation, numerous charting methods, and so on. Those are beyond our scope here, but if you're interested, you can follow up with any good statistics course. Six Sigma is often combined with Lean, called Lean Six Sigma, simply by virtue of implementing both approaches. You can get official Six Sigma training and certification. Certification levels are most often green belt and then black belt. Given Six Sigma's history and focus on eliminating defects in manufacturing enterprises, how well does it translate to information organizations? I've included a couple of case studies to show how that can work. Nelson reviews both Lean and DMAIC and shows how the methodology's 5 phases can be applied generally in the library. In particular, the aspects of library service that can be more easily evaluated numerically are those that lend themselves to improvement through this process. There's a standard library, especially academic library survey instrument called LibQual Plus. Many of you may have heard of that. And analysis data can be subject to the kinds of analysis Six Sigma recommends for continuous improvement. Nelson also introduces the failure modes effects analysis tool. That's another form of risk management. Kumi and Morrow document a Six Sigma approach to a case study of the library collaborating with a 3M corporation to install self-service devices. They used the DMAIC methodology and Six Sigma framework to identify and resolve several problems while developing a formal fault reporting procedure and monitoring capability. Quack and Berry discuss Six Sigma generally and provide a good review of the organization factors that must be in place to implement Six Sigma successfully. Finally, I've introduced some documents you may want to review on program management generally and how the program manager's role in information organizations is changing. Gerard discusses this in the context of software development, where a program may consist of dozens of interrelated projects and what kinds of skills that program manager might need. Chang and Bright discuss the changing roles of middle managers in academic libraries specifically. Among other things, the role middle managers play in reviewing, planning, and implementing projects is discussed, along with collaboration and partnerships and the middle manager's role in helping the organization achieve new levels of total quality management. So that's a little bit of the view from farther out than we've been looking. And I hope it adds perhaps a layer that bridges the gap between where we've been and very high-level perspectives you've been reading in Bowman and Deal. It's likely that at least some of you will end up here. And although it will take more than this course to prepare you, I hope that this at least sets the stage so you'll have an idea of what to expect and how to prepare. There's a dearth of recent articles in the library literature on adoption of some of these approaches, but from what I can tell, libraries, museums, and archives are taking them seriously and adopting the principles, if not the practicalities and specifications. So anyway, thank you for watching. I look forward, as always, to reading your commentary and looking at your assignments.